Hello, welcome. We'd love to introduce you to our Team B2 for South Tacoma Auto. We have teammates Justice, Anthony, Shrisha, Nam, and Erica. We had the fortunate opportunity to work with Jacob Tice as a part of the company. Let's go over a brief overview. We have a few beliefs and findings that if you hire the right employees, you'll be able to decrease the turnover rate of employees and significantly improve tenure, productivity, and sales. Historically, South Tacoma Auto, as well as all used car business industries, they have about a 40% employee tenure. So for the purposes of our project, we want to help this independent mid-sized company with their tenure and find a way of what is really the bottlenecks that are causing these issues. And our main goal is to determine attributes that affect employee retention and how we can improve their process with recruitment. So at high levels, we're going to find out how we can improve their employee retention. We had some architecture and data methods that we went through for our project. Since South Tacoma Auto did not have a CRM, we made sure to redact their PDF files and convert them into CSV formatted files manually. And as a solution, we wanted to gain insight of best practices and characteristics for their future with transforming experiences for their employees. We also used machine learning as a way to better understand significant factors that affect their employee retention.
So far, past year, our project had included various steps. And first, we learned that South Tacoma Auto didn't have a data system of their employees. So we went through all of their redacted PDFs and created basically a data collection system for them. And that's how we started our modeling and our analysis. And we did all the forms of analysis to include descriptive, diagnostic, predictive, and cognitive. Towards the end of the project, we did include an employee survey, which turned into a word cloud. Then we had a project documentation, which includes our Power BI and Assure machine learning. And then we came up with a recommendation. During our data collection, like I said, we had to take their previous and current employee PDF files. We entered in all the data that we had. We uploaded it to an SQL server for later analysis. We ended up having about 25 different variables, but some of the metrics that we included were position title, years of experience, and education level. And then with having this structured data, we were able to implement it into the Power BI and the Azure machine learning. So we did conduct the employee survey. It was towards the end of the project. And here's an example of, we want to know that not just on how to hire future employees, but what the current employees found that was important to them. And Nam will be explaining the details of the findings of the survey later.
Thanks, Anthony. Thank you for the details. Coming to the review issues, assumptions, and concerns we had until now, our predicted model initially had noted start date, age at hire, and start wage as significant variables in predicting the tenure of the employees. However, we had little data and we were not confident to conclusively say that these are the only factors that are significant within our model. Including more data would be more helpful in producing more accurate solutions to increasing the tenure. We are currently we currently implemented the employee survey, and we also got the results back from the employee survey, which we implemented in a word cloud, so that we would know what factors are really concerned with the current employees too. And the analysis performed until now are descriptive, diagnostic, predictive, and cognitive, and including employee survey findings. We have done all these analysis using tools such as Power BI, Azure ML, Word Cloud, and these analysis are clearly explained further by uh, Justice.
Thank you, Shrisha. As mentioned before, we used all these redacted PDF files and converted it to CSV to where we could use the data for these dashboards like I'll show you here. So this is our first dashboard with our descriptive visualizations. Here we just look at the count of employees by position, with the leading being the sales associates, lot attendants, and front desk. And this is for past employees going back to 2013. We see the count of age by hire. You can see the pattern between the 20 and 30 range. Education level, with the vast majority at high school, and then the male versus female. We also took a look at a lot of other different metrics. Here we're looking at the tenure on people who were terminated versus resigned, and seeing a higher amount of tenure with those who resigned. Here we're looking at the average tenure by position title. As we get down here, there are outliers because there's only a single data point. So don't get too intrigued when you see 59 as the tenure. We look at count of start date by year, and we can also take a peek at the count of end date by year. And with this one data point, this isn't a fall off, this is just a limited amount of data. Going into our diagnostics, we looked at the average of tenure by annual wage, with the average annual wage of STA down the middle. We took a look at the average tenure by hired position title, and we looked at the resignation termination based on position title. And with the diagnostics, you can have a much better understanding of the data and how they line up with the rest of STA. Further on our diagnostic, we looked at the average of annual wage by hired position title. With some of the people with a much lower tenure actually fell below average. The average of annual wage and average of tenure by wage type, which was just an interesting statistic to show how hourly employees did actually stay longer. And then here we were curious to see the count of start date and end date, and by resignation termination. And the pattern seems to be pretty consistent for both of them throughout the whole time. And from here, Nam will go over some of the Azure machine learning that was performed.
Nam, you're muted, bud.
So once we are done with the analysis in Power BI with our descriptive and diagnostic analysis, we move on to our predictive analysis using Azure Machine Learning Studio. And so our step right here is to first put the data set that we got from data entry that we completed. And then we edit the metadata to make sure that the categorical variables stay categorical and the numerical variables stay numerical. And then from there, we want to select the columns in the data set to make sure that we want only include the ones that we really want for our analysis. And from there, based on some of the information that we have, when we visualize it, we can see that some numerical variables are very skewed. That is the reason why we applied the log function to make sure that they appear to be a lot more normally distributed. And then from there, we choose the newly created log columns and also put it in the analysis. And the final step is to split the data into train model and test model. And by using the boosted decision tree algorithm, we believe that this is the best algorithm that yields the best R-squared for us. So after running through the machine learning, we have found out that these variables are deemed as important in predicting tenure. The first one is start date. Second one is age at hire. Third one is start wage, W-2 amount, total years work experience, previous work experience are all the variables that we deem it to be important in predicting tenure. And this model that we have created yields an R-squared of 35%, which we believe that it is significant enough in predicting the tenure at South Tacoma Auto. And earlier we have also mentioned about doing analysis on employee survey. And from there, we were able to create a word cloud to identify keywords that appear the most within the answers that were given back to us. So these are the keywords that appear the most. Things like schedule, benefits, compensation, environment, development, balance, flexibility are the topics and areas that the current employees at South Tacoma Auto focus on the most right now. And to give a summary of our project, we have created an employee database from PDF files and digitize it and upload it through Azure's SQL database. And from there, we were able to find out findings, and some of them are about the significant factors from Power BI in predicting tenure, like hired position title, wage type. And from Azure ML predictions, we were able to determine start date, start wage, age, W-2 amount, and total years work experience and previous work experience positions as significant variables in predicting tenure. And from the survey that we have conducted with the employees at South Tacoma Auto, we were also able to create a word cloud with key phrases that show up the most. Our recommendation for South Tacoma Auto in continuing this project is to do more market research in terms of compensation and benefits for their counterparts in the industry, and also gather more data, because one of the concerns that we're having right now is having limited data to do further analysis. And what to look for in future employees to focus on in their hiring process is total years work experience, wage, previous work position. And there are some ways to support current employees, because these key phrases were shown up the most from our survey that we conducted. And things like schedule, compensation, benefits, and flexibility, development, environment, balance are areas that South Tacoma Auto should focus on as we go on in the future. And that is our presentation about employee retention with South Tacoma Auto. Thank you.
Hi, everyone, and welcome to our presentation. We are Team B3, which includes myself, Brianna Harris, Cole Faranchak, Laura Trong, Prathi Prasad, and Ray Lee. We have had the privilege and opportunity to work with the University of Washington Tacoma Institutional Research Group, where our project was focused on UWT undergraduate recruiting insights. I'm going to give you a brief overview of our project. The problem that was presented to us was that UWT has seen exponential growth since their establishment in 1990. However, in the fall of 2019, they saw their first decrease in enrollment. UWT-IR is exploring options where they can utilize and understand data collected on students to help shape the future of UWT. The goal was to better understand factors that will increase undergraduate student recruiting and overall student retention at UWT. However, since we only had a year to complete this project, we really wanted to focus on the highest return on investment within the time frame we were given. So our scope is to present cohesive analytical-driven solutions regarding current student trends and areas of opportunity for new undergraduate student data. The data that we utilized was from the UWT-IR SQL Server. We focused on undergraduate student data for the 2015 to 2020 fall enrollments periods. We used a lot of tools such as RStudio, Azure, Power BI, and chatbot.com. Our solution has three main components, which we will be presenting today, including current student demographic dashboards, predicting future student growth, and the UWT IR chatbot. I'm going to hand it over to Laura, and she's going to give an overview of all we've done this year.
Thank you, Brianna. So here's a high-level overview of all the phases of our project. In the first phase, one of our accomplishments was completing FERPA training for data access. In the second phase, we accomplished exploring current student demographics. In the third phase, we accomplished predicting upcoming student growth. And in the fourth phase, we developed a data-seeking chatbot. I'm going to now hand it over to Ray to cover limitations.
All right, so I'll be going over the limitations and considerations. These are the 4 variables that we found very important with our limitations. So the first one is the 5-year historical data. We took the data from fall of 2015 to 2020. Before that, we thought was unnecessary as it doesn't really represent the current student demographics. Next one is self-reported data, and these are the data that's coming from student submission applications. And as the applications have some parts that are optional, we decided to just use parts that we deemed complete. The next one is internal data. So this is data coming from the University of Washington Tacoma's Institution of Research. And we just wanted to focus on this our school as we have that time constraint of 1 year. And the last one is the COVID-19 impacts. We only have 1 year of data so far from the pandemic, and we can't really make any accurate, like complete recommendations, but with the data that we have, we will try to make the best recommendation as possible. And now I'll be showing the live demo for the descriptive analytics. So if you look on the first dashboard right here, this is the data for age and genders from autumns 2018 to 2020. And we see that the dominant age group is from ages 21 to 34. And breaking it up, we see that the top 3 ages are from 19, 20, and 21. And if we look at the storyboard, we looked at the majors and statuses for students, and we see that the top 3 majors of choice are number 1, interdisciplinary arts and sciences, number 2, School of Engineering and Technology, and number 3, the Milgard School of Business. And now I'll be handing it over to Cole to explain some more analytics.
Thank you, Ray. So we got a more clear picture of our data when using Power BI visualizations during the predictive analytic phase. So we started off here with a flowchart, and it's the total number of new students coming into the University of Washington, Tacoma, and it's broken down by city. At top, you can see very clearly the largest is Tacoma. And then next it gets broken down by which schools in Tacoma. We have Tacoma Community College, Pierce College, University of Washington, as some of the highest ones. In this next flowchart, we have student total again of new students coming in. And this shows the largest place that the students are coming from regardless of location. So you see some of the same entries, such as Tacoma Community College, Pierce College, University of Washington, but also some new ones like Highline Community College and Green River College. Next, we looked at the top 5 community colleges and the top 5 high schools. In the community colleges, you can see somewhat of a plateau here, but in the high schools, you actually see a general positive trend, and it's actually a doubling in this period over this 5 years of the high school applicants here. So next, we looked at the top 5 schools from within Tacoma, and we have the community colleges up here and the high schools down here, and you notice this big gap between here, and that's significant. So what we would do is recommend that our client remain focused on this large number of students in community colleges, and universities, but also remain optimistic of this growth that they're seeing in high schools down here as well. Lastly, we have our prediction for new undergraduate students at the University of Washington, Tacoma, and it has a 95% confidence band interval. The dotted trend line you see here generally has a positive upward trend, but our prediction is flat. The range for our prediction is about plus or minus 200 students, and we believe this model could be more accurate with more years worth of data. Given these conflicting data points, though, we would optimistically predict that there will be a minor growth or stagnation in new undergraduate students in the coming future. With that, I'm going to pass it off to Prati for the next part.
Thank you, Cole. I will be presenting the prescriptive analytics, which we performed using the Azure Machine Learning Studio. So here you can see the data file which we used was consisting of data related to both high schools and community colleges. And then we used the edit metadata pill in order to identify the input variables or the predictors and the dependent variables or the label. The label in our case was the student total. Next, the convert to indicator pill helps us to convert the categorical variables into indicator values. We use the clean missing data pill to clean any missing data in our data set. Moving on, we use the permutation feature importance pill. This pill helped us to identify the most significant variables which were related to our data set. So the alumni child, yes, school type high school, and the school city of Tacoma and school state Washington. And some of the top schools which were relevant to our model was Kent Meridian Senior High School, Thomas Jefferson High School, Aviation High School, and the Auburn High School. So these were some of the good predictors which we used for our model. So the next pill which we used was the training the model. And our model was trained on the linear regression algorithm. And the data split was a 70-30 split, 70% training and 30% testing. And when we evaluate our model, we were able to get the results as follows. The R-squared value or the coefficient of determination was 58%, and the root mean squared error value was 11. We were able to predict 58% of the student total based on our input variables. So I will hand it over to Laura to proceed with cognitive analytics.
Thanks, Prati. Let me go ahead and hop on and share my screen here. All right. So for our cognitive analytics solution, we developed a chatbot prototype that we plan to place on the UW-TIR homepage. And the purpose of this is to help automate processes at the UW-TIR. We want to save our clients time and money on customer service and also provide a solution that generates responses in seconds instead of hours or even days. So I'm just going to give a brief demo right here. This is basically where the chatbot is created. It's a very user-friendly interface where our clients can easily add interactions or actions to build the chatbot model. And then let's hop over here and test the chatbot now that it's developed already. All right. So basically, it's just gonna kind of like guide us through here. It asks us what we need help with. So I'm gonna test it out. Let's try something we see here. So we'll test out policy. And so this is basically more of like a navigation where we want to direct our clients, the customers, to places that links that they can access. So we'll click on FERPA, and it basically directs them to a link where they can find information on FERPA. And then let's close out of that. Let's say we're not interested. It'll take us back to the default, which takes us back to the home page, and there we can navigate again and try something different. So now I'm going to try visualizations. So visualizations. Okay. So here we can see that the chatbot does not recognize what was plugged in. And what's nice about this is that easy interface that I had talked about, where the clients can just easily hop in and train the chatbot. And over time, they can develop a very robust model that can be used on their site. And then another very neat feature about this is the reports. So our clients can easily track the use over time. They can see how many chats they've received during the different times as well too, and they can see the popularity of certain keywords that come in. And if they're not too familiar with this too, they can easily take lessons on this. Chatbot user face is very friendly and allows them to take classes and learn the tool. So now I'm going to hand it over to Brianna.
Thanks, Laura. Let me start the presentation one more time. So based on everything you've seen thus far, we've really accomplished a lot. We have 3 main recommendations for the future of UW for them to continue emphasis and expansion on top schools such as interdisciplinary arts sciences, School of Engineering, and the Milgard School of Business, to continue recruiting from top schools in Tacoma and focus on community college, where a lot of their recruits are coming from, and utilize chatbot features to understand what questions are being asked or what visualizations can be added to the UW IR site. The good news is our solution is fairly low cost for our client. UW IR is a database team, meaning they're already utilizing a lot of these tools within their daily jobs. The only fee will be the chatbot.com subscription, which they've already incorporated into their budget for this year. So you're probably wondering, how does this impact the problem that I presented at the very beginning? Well, we have a few utilization impacts that we think will really change the focus of UW's future. Faculty and staffing totals can be better predicted with the prediction of incoming students, targeting their marketing to really get the most out of their money on what they invest in, budget and financial planning, focusing on top schools, or maybe they need to focus on some smaller schools that are really in demand for majors, improving data access and awareness for faculty to make data-driven recommendations, and increasing UW IR capacity by taking away some of that customer service aspect in order for them to create more visuals and stronger data for their school to use. Now, this comes to the conclusion of our presentation. I would like to thank the UW IR team for being such a great partner to work with throughout this year. We've really grown a lot and truly appreciate you guys, as well as Dr. Haluk and Dr. Helser and the Center for Business Analytics team. We really had such a great time this past year learning a lot about UW IR, something really passionate since we go to this school. Now is the time for question and answers or comments or concerns. Thank you so much.
Hi, my name is Lindsay Grays, and I have the distinct pleasure of kicking off today's presentation as a part of the 2021 Applied Project Showcase on behalf of Team B4. Team B4 consists of myself, Benjamin Hill, Ian Lynch, and Rex Corey. Before continuing, we'd like to give thanks to our client representatives at Communities and Schools of Tacoma, Nova Hernandez, Lynn Fant, and Abby Butter, as well as acknowledge and thank our Center for Business Analytics leadership team, Haluk, Michael, Merv, and Heidi. Thank you all. To frame our conversation today, we have 3 goals. 1, provide background about Communities and Schools of Tacoma, as well as a full project overview. 2, discuss our analytical solution, as well as provide a demo of our tool. And 3, review our recommendations and next steps. And if there are any questions, we invite you to join us during our poster presentation. For background, Communities in Schools is the national youth-serving nonprofit organization founded in 1977 by Bill Milken, whose mission it is to surround students with a community of support, empowering them to stay in school and achieve in life. Communities in Schools, also known as CIS, planted its roots in Washington State in 1991 and formed its Tacoma affiliate chapter in 2001, which we know as Communities in Schools of Tacoma, or CIST. Currently, CIST is partnered with 5 schools and 30 different youth-serving programs through their outreach initiative. Running all of this incredible work, we're in Tacoma as a small but mighty team of 10, 3 of whom are our main contacts: Executive Director Nova Hernandez, Database Administrator Lynn Fant, and Director of Resource Development Abby Butter. So Team B4 has been collaboratively addressing what is essentially a funding stream challenge. CIST's total revenue last year was $337,000, 85% of which came from corporate and grant donations, which are historically restrictive funds. Thus, CIST's goal has been to better understand their current constituent data to increase individual donor contributions, which would allow for more unrestricted types of funding to grow their strategic priorities and staff. Our goal was to provide them with an elegant tool via Power BI that's both interactive and provides insights about their donor landscape as a means to better leverage individual donorship and their donor behavior from a fundraising perspective. As you can see here, there's good opportunity to grow individual funding, which would positively impact their standing in the third sector market. For a rundown of how Team B4 approached project management, I'll hand the figurative mic over to Ian Lynch. Ian, over to you.
Great. Thank you, Lindsay. So throughout this last year, we have structured our project around agile methodology using Azure DevOps as our main project management tool. It has allowed us to manage our product backlog, Kanban board, and sprints throughout this project. So here you can see a snapshot of the Azure DevOps landing page and the Kanban board we use to structure our 2-week sprints. Next slide. Here is a brief snapshot of our current sprint and what we have accomplished. We are currently in our 4th sprint of the quarter and working on 4 user stories. Throughout this project, we've been able to complete 14 sprints that ran for 2 weeks each, for a total of 45 completed user stories and 215 completed user story points. Next slide. So throughout this last year, we have structured our project milestones in phases. In phase 1, discovery and planning, our team worked to better understand the client's data and industry. In this phase, we completed a market and organizational analysis. In phase 2, analysis and design, we began finalizing the project scope, project management methodology, and data modeling and storage. In phase 3, we began the development of the deliverable, implementing the data architecture and business analytics solutions. And finally, in this current quarter, we are working to complete the 4th phase of the project, the deliverable. In this phase, we have implemented a development cadence that relies on iterations between the client and the team, where we use the client's feedback to iterate on the current dashboard. In addition to the development cycle, we have developed a robust knowledge transformation package that will help the client manage the final product independently. Next slide, please. And here, throughout the course of the year, we have completed multiple milestones and achieved a handful of accomplishments. Here we have a brief list that highlights the activities we completed throughout our time working with CIST. In the current phase of this project, we've hosted a client workshop, developed a Power BI training video, a data transformation plan, and a natural language Q&A tool. With that said, I'll hand it off to Rex.
Thank you, Ian. I'm going to be talking about our data architecture. On the slide you see before you, it kind of goes over how we started our journey and some of the steps we took along the way. We developed a data dictionary early on. We looked at the different tables and columns available through LGL and what their contents were. We then looked at the data flow from LGL to CIST. Where did it come from? How was it used? Where did it end up going in the end? We also looked at the data itself. We looked at its relationship to each other, the effect that it has primarily on gifting amount through multiple data analysis and statistical methods. Next slide. Throughout that process, we developed a robust data architecture that started with a CSV download from LGL. After that, we then had a Visual Studio built ETL that went through and grabbed all of the CSV files, converted them, and uploaded them into an Azure database. That Azure database then had dimensions and facts built on top of the LGL imported data. And those dimensions and facts were derived from an ERD diagram that was developed. And then once that information and tables made it into Power BI, we then related all of those tables together in the data model. Next slide. Saying that, we also had some internal discussion between us and some discussion with the client, and the hurdles for that data architecture discussed were very high. So we looked to scale it back a little bit. In doing so, we then looked at Power Query Editor through Power BI, and it's integrated with Power BI itself. So we can deliver one solution to the client, and all they'll have to do is download that data out of LGL into CSV files, refresh within Power BI, and they'll have an updated dashboard. Two of the deliverables that we are delivering to them are the Q&A visual and the donor dashboard itself. Next slide. We also, throughout this journey, developed a predictive model that looked at first-time donors and their likelihood to donate again. In that we focused on 3 areas: the propensity, affinity, and capacity. We developed an Azure model that would predict whether they were likely to donate again, and then we integrated that Azure model into Power BI through their AI insights. Next slide. Now I'm going to go ahead and do the demo of the dashboard. I'm pulling it up now. You should see the landing page of the dashboard right now on your screen. This landing page is concerned with geography, which is one of the pieces of information we have about the donors. As you can see here, this is the LA area in California depicted on the map. If you look at the map, it's broken apart by zip code. The color of the zip code, darker reds, mean that we got more gift amount from that area, more gifting dollars, and the lighter reds mean we got less from those areas. There's also overlaid with median disposable income for each of these areas, so you can see where your more affluent neighborhoods are versus your less affluent neighborhoods. On every page, there's a number of slicers that can be used to change the visualizations on the screen. For one example, instead of looking at all kinds of gifts, you could look specifically only at monetary gifts, and doing that updates each individual visual to do that. Each of the slicers are capable of doing that. Beyond the slicers over here, the visuals themselves interact with each other. Down here, we have a matrix breakdown of those gifting amounts and donor amounts and average amount per donor and number of donors for each of these different cities depicted up here. If I were to click on Los Angeles, the map and the top 15 donor visual over here would zoom in to tell me who my top donors are for that area plus their donation amounts. And then it shows me on the map within that LA area where are those donors located based off of zip code. Our next slide is more concerned with gifts over time. So this is our trend analysis. It has a number of different measures in them: gifting amounts, added donors, the individual gifting percentage trend over time. Each of these visuals has a date hierarchy, so you can scale up to see it solely by year in this example, or go back down the hierarchy to see it by year and month. So you can time travel a little bit there, as well as using your date time slicers over here. You can time travel as well. The next slide is what we call the donor dashboard. The idea here is you have a certain basket of donors that may have gifted within a certain amount of time, but they have not gifted recently. And you can define how long to look back and what the recency is with this slicer over here. What these visuals do is they break out individuals and organizations in order by their gift amount for those that have donated within some time frame but have not donated within, say, the last 6 months. So you can target them to try to get donations. Also on this is a tracking of all of our big donors. So these are top 15 donors. If you were ever a top 15 donor, this visual shows how you trended over time. So I can see that this donor, constituent 417, donated high in 2019, but dipped really low in 2020. So something happened with our relationship there, you would think, to cause that decrease in donations. And that's something we want to target. All of these slides that have constituent names, you can also right click and go drill through to donor detail, which is the next page we'll look at. On the donor detail, you'll see a lot of information about specific donors. You can see their address, their phone number, groups they belong to, annual events, any donor information, just general information we have on them. You can see their donations over time, and you can see where their gifting has gone. What campaigns, events, funds have they gone to? And are they just gifting money, or are they gifting in-kind gifts? You can see that breakdown as well. The next slide is also looking at donations over time, but it has every individual constituent broken up by year. So you can see where those gaps are for a constituent might donate 1 year, but not the next year. You also have your filters available, so you can look at donations to a specific event if you wanted to. So you can come down here and see, this is all my donations for event 1, who donated to that and when. Same thing for campaigns and other items. On the next slide, we were looking for relationships between some of the data that we have numbers on, so our numerical data, and gifting amount. So we looked at, when we send more mailings and they're open, does that lead to more gifts? Or when we send more invitations, does that lead to more gifts? Does a higher capacity lead to more gifts, right? Equity and home value, and what's the relationship to gifting on those? Our next slide looks at what we were calling touch points. In LGL, we really only had 3 touch points, which was invitations, mailings, and events. So these visuals all depict what mailings, events, and invitations has an effect on gift amount. And so you can see that in these 3 visuals, as well as a timeline down here between the individual dimension and gift amount. The next part of the dashboard is all about clusters. There was a request to understand their donors based off of how many gifts do they give, what's their gifting amount, and what's their capacity. And so this allowed a cluster analysis to be done based off of those 3 data inputs, and then those clusters were outlaid and then put on a scatter plot, so you can kind of see, is there a trend between those different clusters? Where do they fall on, and define them? The next slide is what we were talking about for our Q&A visual. On our Q&A visual, we have suggested queries that we've developed with the client. So this one is looking at donors over a certain amount in a certain time frame, only monetary. But this is a natural language query. So the idea is you can type in something just by you can type in something like this, and it'll show you a scatter plot that's your top 20 donors, so the people who have donated the most based on equity, and then what is the gift amount that they've given as well, right? And you can change that top 20 to top 50, or however you want to type it, because you're just talking to the natural language processor here. This is built over our data model. The idea here is we've developed a lot of visuals, but maybe they want to see something that isn't here yet. So this is here to allow them to do that. So this is an example of a visual that's not in there either, but maybe they want to know how, which events got the most invitations. This is someplace they can go and ask that question and see. The other item that was developed during this time period was the predictive model. This is the Power BI file that's hooked into Azure Machine Learning Studio. In here, you can see the propensity of a first-time donor to donate again. We can see where they're located at, what events they did, what the prediction is, where do they fall under, if they're a multiple donor or not. And we can look at solicitation score, which is the amount they donated times the probability that they will donate again, to let us hit the bigger, more affluent and bigger donors when we can. That's it for our demo. I'm going to go ahead and pass it back to Ben Hill for next steps and recommendations.
Thank you, Rex. As you can see, we've delivered a viable product that CIST is starting to use. However, it can be improved, and to do that, we've outlined a few of our key high-level recommendations here. In addition to data cleanup to make the tool more useful, CIST may want to find resources to maintain and upgrade the dashboard. Now that they have a viable product, CIST can investigate how to automatically integrate Little Green Light into the dashboard and more fully leverage Little Green Light's campaign tracking capabilities. Moving forward, this establishes the groundwork necessary to build a robust donor predictive model, which we think could be of significant value to CIST. Next slide, please. After completing the project next steps, we recommend that CIST's next project be to build that robust predictive model. We've shown this diagram earlier. To help CIST move forward with that effort, we have conducted research into the general factors that help define those who donate to nonprofits. Those high-level factors are shown here, gathering prospect and donor data on propensity, affinity, and capacity. During our project, we used proxies for these factors. CIST should move forward with building on a robust and accurate set of factors for themselves. With this additional data, a customized predictive model could be developed to take CIST's fundraising to the next level. And with that, I'll return this over to Lindsay to close us out.
Thank you, Team B4, and thank you all for your time. And this concludes our presentation as a part of the 2021 Applied Project Showcase in collaboration with CIST and the Donor Analysis and Power Growth Project. If there are any questions, please join us during our upcoming poster session.
you.